Hello friends, today we will see one more example related to finite automata, that is design a finite automata over input AB where accepting the string where the number of A's are divisible by 2 and number of B are divisible by 3. Means what? If I having the combination A, B, 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 so B it is coming 3 times and A it is coming 2 times. So A it is divisible by 2 and B it is divisible by 3. Yes, it is the string, complete string is divisible by 2 as well as 3. Consider the next string, that is A, B, 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 A, B, B. If you go through the occurrences of A, having the occurrences of A, that is 4, and what about B? So the occurrences of B, it is 1, 2, 3, 4, 5, 6. So the occurrences of B, it is 6. And when I say A is divisible by 2, yes, it is divisible by 2. It is getting the remainder, that is 2. And 6, it is divisible by 3. So again, I am getting the remainder as a 0. So if consider the another string, if it is having A, B, B, B. So if I pass this input to a machine, the occurrences of A is just only 1 and the occurrences of B, it is 3. But what it says? It says that A are divisible by 2 and, right? So that A and B, it must be divisible. A must be divisible by 2 and B must be divisible by 3. It should not be like that. Ki yahan pe, if you see here, A is equal to 1. So it is not been divisible by 2. But for B, it is divisible by 3. So this string should not enter into the final step. If it's having, that is A, B, 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 so definitely this string must enter into the final step. So we will see how to design a machine. So A must be divisible by 2 and B divisible by 3. So if you go through the occurrences, fine, that is divisible by 2 and divisible by 3, how many states we require? We require total 6 states. That is 3 multiplied by 2. If it is say A is divisible by 5, A is divisible by 5 and B is divisible by 3. If it is this type of example, at that time I require total 5 3s are 15. That is 15 states I require. So consider that is A divisible by 2. We will start the machine from the state that is Q0. If I having the input A, so by processing A, it will reach to the next state, that is to the Q1 state. Now consider again, if I having the input A, so it is divisible by 2. So the occurrences of A, it is 2. 2 divisible by 2 S. I am getting the remainder as a 0. So A. So which state is my final state? My Q0. It's a final state. Now check for the occurrences of A and B. Now consider if my input is A, B, B, B and A. So by processing A, I reach to the Q1 state. Now it's having 3 times B. So what I will do, by processing B in Q1 state, I reach to the next state, that is to a Q2 state. Again in Q2 state, I will process B. I will reach to a next state, that is to a Q3 state. Now afterwards again B it's having, and after B I having the occurrences of A. So A, B, B, from Q3 I will return back to a state of Q1 by processing B. So just go through the input S. A, the occurrences of A it is 2 and the occurrences of B it is 3. So A it is divisible by 2 and B it is divisible by 3. So just go through A, B, B, B and A. It is reaching to a final state. What about the occurrences of B? If the input starts with B, Here the input is starting with A. Now the input starts with B. B, 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 A, A. So this string, it is again divisible by 2 as well as divisible by 3. So in Q0 state, if it's having B, so by processing B, I reach to a next state, that is to a Q4 state. Again one more B it is there. So by processing B, I reach to a next state, that is to a Q5 state, and about last B, B, I return back to a state of Q0. And next go through, after B, I having the occurrences of A. So from Q0 state, it will process A, reach to Q1 state. Again by processing A, it return back to a Q0 state for this string B, B, A, A. What if it's having a random, that is B, A, B, A, B? So from Q0 state, I am processing B. By processing B, I reach to Q4 state. What about Q4 state for A? Where it should move? It should move to the state, that is to a Q2 state. It should move to a Q2 state. B, A. Next B. Now currently I am in Q3 state. B, A, B. What about again A in Q3 state? I will return back by processing A to a Q5 state, and again B, it will return to a Q0 state. Same consider for the Q2. If I am having the occurrences of, that is A, B, A, then B, B. A, B. Now currently I am in Q2 state. What about again A? So from Q2 state, by processing A, I reach to Q4 state. Just go through A, B, A, B, B. So currently this string, the machine should accept. Same go for Q3 state. If my input is A, B, B, that is A, B, B, A, again A. If you are having in this way, that is 4 times A and B. So A, B, B, A. So in Q5 state, I have to process A. So it will again return back to a Q3 state by processing A. Means A, B, B, A, and B. So this complete string, the machine should accept. Why? Because the occurrences of A, it's having 4, and the occurrences of B, it's having 3, and this is divisible by 2. So the remainder is 0. So in this way, you have to design. If suppose the occurrences of A and B both is null, so null divided by any 2 or 3, definitely it is a acceptable state. That is, the machine should enter into the Q0 state. So this complete machine is related to a number of A divisible by 2 and number of B divisible by 3. I can design a machine in different way also. Means what? I have designed with 2 columns and 1 column with 3 states. So if I want to design in a different way, I can design in this way also, this machine. What I will do? Q0, B, Q1, B, I reach to Q2 state, and from Q2 state I will return back by processing B into a Q0 state. Next one, same as Q0, by processing A, I reach to Q3 state, and from Q3 state I will return back to Q0 by processing A. Same as in Q3 state, if it's having B, so again by processing B, I reach to Q4 state. By processing B, I reach to Q5 state, and next again by processing B, I return back to a Q3 state. What about A in between Q1, Q4, Q2, Q5? It should be, that is, by processing A, from Q1 state I will reach to Q4 state, and from Q4 state by processing A, I reach to Q1 state. Same A, in between Q2 and Q5. By processing A in Q2 state, I reach to Q5 state, and from Q5 state, by processing A, I reach to Q2 state. If you see this diagram it completely a reverse. But both the machine, it is correctly accepting, that is a number of A, it is divisible by 2, and the number of B, it is divisible by 3. So in this way you can easily design. Remember that if I say, in the previously I have said that if the number of A, it is divisible by 5 and number of B, it is divisible by 3, so we require totally 15 states to design the machine. Hello friends, next example is to find out, so design a DFA that reads a string made up of letter in the word chariot and recognize this string that contain the word cat as a substring. So from this complete word, that is chariot, now we are going to find out a substring, that is cat. And when the string, it contains a substring cat, then the machine should enter into the final state. Say consider is to find out a substring by using a concept of DFA. So design a DFA that reads a string made up of a letter in the word chariot and recognize this string that contains the word cat as a substring. So now we are going to find out in a letter a substring cat. If it appears, then the machine should enter into the final state. But what will be the combination? The combination must be of 7 letters only. Means what? If my string starts with T, R, I, then cat. So the machine should enter into the final state. Why? The substring cat, it is appearing. It may appear at a beginning also. C, A, T. Then afterwards combination of this letter might be H, C, I, T, T, I, anything. But in this string, a cat, it appears. So the machine should enter into the final state. So the cat substring, it may appear in beginning, middle, or at last. But the combination must be of 7 letters only. Consider, now we will design the machine. Consider having just only a string, that is cat. So from the initial state, that is Q0, I am processing C, input C. By processing C, I reach to a next state, that is to a Q1 state. Consider next letter is A only. In Q1 state, I am going to process A. I reach to a next state, that is to a Q2 state. And in Q2 state, my next letter is T. My next letter is T. So by processing T, I reach to a final state. Just only a cat. Now go for the combination. Why? Because we are having the 7 letters. The 7 letter appears anywhere. So in Q0 state, it may starts with H. Means what? H, C, A, T. Or H, C, A, T. So that's why we are having the loop of H, self loop, in a Q0 state. Might be the next letter, maybe of A. Means the string may be A, C, A, T, or A, C, A, T. So again a self loop of A. Self loop of same as for I. Self loop same as for I. Next O and T. Why not C? Why? Because in Q0 state, by processing C, I am reaching to a next state. Why? The substring, we have to find out a cat, and the first letter is the C. So that's why in Q0 state, by processing C, I have to move to the next state, that is to a Q1 state. If you go through this scenario, the combination may be H, T, I, C, A, T. Means H, T, I, this letter, it will going to process into a Q0 state only. And the moment when I find a letter that is C, my machine should reach to a next state, that is to a Q1 state. Again for A, Q2 state, and again for T, it reached to a final state. So in this way, we will complete the next state, that is Q1, Q2, as well as for the Q3. Now consider if my string is H, C, 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 A, T multiple times C. So by processing H in Q0 state, it will going to remain into the same state, into a Q0 state. Next letter is a C. By processing C, I move to a next state, that is to a Q1 state. Now here might be, there will be a multiple occurrences of C. So where to process this C? Again, after C, if you go through having a letter A and T, so the machine should enter into the final state. So in Q0 state, by processing C, you should not return to a Q0 state. The reason is that if you return to a Q0 state, again, the multiple times if it is having C, here it will going to be represent in between Q0 and Q1 state only. So by processing a C in Q1 state, it should remain, or it should have a self loop of C in a state of Q1. Means just check H multiple times C. H, by processing first C, it will move to a Q1 state, and for the rest of the 2C, it will going to have a self loop into a Q1 state only. And next AT, by processing A in Q1 state, it will reach to Q2 state, and from Q2 state, by processing T, it reach to a Q3 state. Now, if it is having H, A, R, I, O, T, any of the letter, means what? H, C, again H. And then afterwards C, A, T. So H, by processing H, it remains into a Q0 state. By processing C, it will reach to a next state, that is to a Q1 state. Again, we are having a H. So from Q1 state, I will return back to a Q0 state. For which letters? For the letters of H, for the letter of I, for the letter of O, for the letter of T, and for the letter of R. Means in this, any of the letter it is coming in Q2 state, I have to return back to a Q0 state, from Q1 state to Q0 state. And by processing A in Q1 state, I will reach to a next state, that is to a Q2 state. Next, in Q2 state, say suppose if I having T, C, A, C, A, T in this way. So cat, it is coming in this string. So the machine should enter into the final state. Just go through Q0 state T. So by processing T, it remains into a same state Q0. Next letter is C. By processing C, I reach to a next state, that is to a Q1 state. By processing A in Q1 state, I reach to a Q2 state. And what about again C? So I have to return back by processing just only a C from Q2 state to a Q1 state. Now just go through CACAT, CACAT. So the machine is entering into the final state. But what about rest of the letters? That is for consider, that is A. Next one for I, O. So from Q2 state, if any of the letters it is coming except C and T. Why? Because by processing C, it return back to a Q1 state, and by processing T, it reached to a Q3 state, that is to a final state. So except C and T, the rest of the letter, that is H, comma, A, comma, R, I, O. So these are the letters in Q2 state. By processing, I again return back to a Q0 state. So at last, what are the letters we have to process into a Q3 state? So the moment when a string, it contains cat as a substring, it is reaching to a final state, that is to a Q3 state. And in Q3 state, it have a self loop of all the letter, that is C, comma, H, comma, A, comma, R, then afterwards comma I, comma O, comma T. Why? The reason is that if the string it contains a substring as a cat, the machine is entering into the final state, that is to Q3 state. And after cat, say suppose after cat, consider this example, after cat any of the letter it appears, that is I, O, T, the machine should enter into the final state. Why? Because in this string I having a substring cat. So the machine should enter into the final state whenever the string it contains a cat as a substring.